All right. Ladies and gentlemen, distinguished guests and esteemed researchers, a very good morning to you all on the second day of Moratuwa Engineering Research Conference, MERCon 2023. I'm delighted to welcome you back to this remarkable conference where innovation and expertise converge to shape the future of engineering. Each moment spent here is a step towards progress, and your presence adds immense value to this gathering.
Today, as we embark the second day of MERCon 2023, we are honored to have a distinguished personality among us to introduce our keynote speaker for this session. I have the privilege of introducing Dr. Chamir Edisuriya. Dr. Chamir Edisuriya is a senior lecturer of Department of Electronic and Telecommunication Engineering, University of Moratuwa, and also courtesy postdoctoral associate at Department of Electrical and Computer Engineering, Florida International University, USA. Furthermore, he is a founding chair of IEEE Sri Lanka section Signal Processing chapter, and also has several research collaborations, including the Howard University, USA. He is a special session chair of MERCon 2023.
His wealth of knowledge and experience in the field of engineering is truly commendable. So without further ado, please join me in welcoming Dr. Chamir Edisuriya to the podium.
Good morning, everyone. I am greatly honored to introduce our keynote speaker, Professor Shanika Karunasekara. Professor Karunasekara is a professor, obviously, in the School of Computing and Information Systems and the Deputy Dean Academic in the Faculty of Engineering and IT at the University of Melbourne, Australia. Professor Karunasekara completed her BSc in Electronic and Telecommunication Engineering at the University of Moratuwa, Sri Lanka, with first-class honors in 1990. She was the recipient of the UNESCO Gold Medal for the Best Engineering Undergraduate at the university in 1990. I am glad that we both graduated from the same department. However, by the time you graduated in 1990, I was a grade 1 student. In fact, this indicates your experience and expertise. Professor Karunasekara completed a PhD in electrical engineering at the University of Cambridge, UK in 1994. From 1995 to 2002, she worked for Lucent Technologies, Bell Labs Innovation, USA, where she was a distinguished member of technical staff. Professor Karunasekara joined the University of Melbourne in 2003. Her current research focuses on real-time analytics and data stream mining, with applications in social media analytics and autonomous traffic management. Professor Karunasekara has extensive research interest in distributed computing, network intrusion detection, sensor networks, social networks analysis and mining, mobile computing, software engineering, and STEM education. She has published widely in high-ranking journals and conferences in her research disciplines. Furthermore, she has also established research collaborations with many industries and government bodies. Furthermore, Professor Karunasekara is a passionate educator who has won several excellences in teaching awards, including the National Carrick Citation in 2007, the Kelvin Medal and Excellence in Teaching Award from the Melbourne School of Engineering in 2006. Today, the keynote speech is on a timely theme, and I would like to warmly invite Professor Karunasekara to deliver the keynote. Thank you very much.
Thank you very much for that kind introduction. And thank you for inviting me to deliver a keynote at MERCon 2023. I'm really honored to be here, to be invited as a keynote speaker, but more importantly, coming back to my university to deliver a keynote is a special event. So the title for my talk today is towards an innovation-driven economy, harnessing the power of big data, high-performance computing, and artificial intelligence. Yes, it's a bit of a mouthful. Hopefully, in the next 40 minutes, I'll be able to unpack some of this, and you will go with some idea of what this topic is about. But before I start, I thought I'll give you a little bit of introduction about where I come from. I'm from the University of Melbourne, so I thought this is timely to introduce University of Melbourne to you. So University of Melbourne is a leading university in Australia, and it's located in the heart of Melbourne. So what you see here is the city of Melbourne. The university is located walking distance from the central business district, but still it's one of those beautiful universities that has a lot of character. So we are a Melbourne university, mainly in Melbourne. However, we have a very global outlook, and this is a part of that. So just a bit of statistics, not that statistics mean a lot everywhere. In terms of statistics, University of Melbourne is ranked number 14 in the world based on QS rankings. This was a significant uplift in the ranking this year. It was around the 30s. And the number 1 in Australia based on the Time Highest Education rankings, 65,000+ students, 40% international students, and 450,000 living alumni. So it's one of the very old universities and one that is really holds its esteem from its alumni. So getting to the Faculty of Engineering and IT, where I come from, the Faculty of Engineering and IT has 3 schools. So a mechanical, electrical, infrastructure called civil engineering here is in one school. Then the School of Computing and Information Systems is the second school. And the third one is chemical engineering. Now, as the introduction said, I graduated with a degree in electronics and telecommunication engineering from here. I'm in the School of Computing and Information Systems, doing more research and development in computing. But what this tells you is as a graduate here, if you graduate with an engineering degree, you can do many things beyond just what you're trained for. So that's a key message for you to take from there. So in the university faculty, we have different research teams, but here are some of them, and I'll show you quickly a lot of the research centers associated with them. So in case you're considering Melbourne as a destination for your postgraduate work, look at these research areas, find academics who work in these areas and contact them. And we have lots of Sri Lankan students doing PhDs in Melbourne, so you have many opportunities there. So that's the brief introduction to Melbourne. And with that, I'll get to an overview of my talk. So based on the title, I'm supposed to talk about the role of AI in innovation. So I thought I'll start with a brief historical perspective of innovation and AI. And considering that this is a very diverse audience, I'll give a little bit of a tutorial on what AI is and what we are talking about. Then I'll talk about some recent breakthroughs in AI, and I'll talk about our research contributions, very briefly, what I work on with my research team, and then about the future and conclusions. Okay, so given that this is about innovation, I thought this is a good place to start because step changes in innovation is marked by this what you call industrial revolution, because that is where many engineering step changes happen with this revolution. So in the 1800s, we talked about mechanization, water, steam, and steam powers. 100 years later, Industry 2.0 is about mass production, electricity power, assembly lines. 3.0, computers, automation. And that's around when we start this digital world, computers come into life, and that is where the digital revolution started. Then coming to Industry 4.0, we talk about machine learning. That is the step towards AI. And then finally, 2020 and beyond, we really don't know where we are going, but we are hoping that we'll get some sanity here with AI, with the human coming to the loop. And that is what I'll talk about today. Okay, so the talk today will be about Industry 4.0 and the role of big data, AI, and high performance computing, what role it has played in this last 10 years or 12 years in the Industry 4.0, and what we can expect to happen in the next 10 to 20 years in this world. So when I talk about AI, as you can see, I talk about big data and high performance computing along with AI, because AI as it is not that useful. Why AI became this useful is because of data and because of computing power. So this goes hand in hand, as you see. So to start with, when did we start talking about AI? It was a long time ago. Okay, so this Alan Turing, he's a British computer scientist. He's considered as a father of theoretical computing. And in 1950, he proposed this concept called, now we call it the Turing test. That time it was called the imitation game. He talked about a human observer sitting in front of this black box and asking a question from this black box. But there are two people behind the black box. One is a computer, one is a person. So the intelligence, as he defined, was if the human person cannot identify the difference between the human answering the question and the computer, we have an intelligent system. So do you think we are there yet? Yes, no? Maybe, okay. So then later on in 1956, John McCarthy, an American computer scientist, he brought the word artificial intelligence to life. So his definition of artificial intelligence is the science and engineering of making intelligent machines. So he coined the term artificial intelligence. Again, are we there yet? We don't know, right? It depends on what intelligence means. So it was a long time ago in the 1950s that this particular concept was first proposed, but artificial intelligence has had a bumpy pathway. So we had several booms along the way, but they didn't go for too long. Boom 1 was in the 1950-60 time frame. Boom 2 was in the 1980s. Now we are in the third boom, still going up. You don't know whether it will go down or up coming to the future. So Industry 4.0, 2010, really overlaps with this boom of artificial intelligence, big data, and high performance computing. And that's what we are experiencing today. So if you talk about boom 1, which was a long time ago, it was just associated with the invention of the computer, and there was a lot of excitement of digitization, and people thought, okay, this is intelligence. Okay, at that time, there were scientists who said within 10 years, a digital computer would become the world's first champion, chess champion, discover and prove important new theorems, and even write music. Okay, so are we there yet? Again, the question is quite not clear. Okay, so just like now, as you know, people are very scared about AI and what it's going to do. The same scares were there in the 1950s. There were government bodies trying to put regulations on AI, thinking that this AI is going to take over the world and bad things will happen. However, these pioneers did not really deliver their promise, and that resulted in that first wave dying. And then came the next wave. And this is the scientist who was really pushing the second wave. The approach was different. So his view was that we all have a lot of knowledge. Can we code all that knowledge as a knowledge base, as a rule system, which is called the expert system? And then through this rule engine, people can ask questions and make decisions. So this is what those bank loan systems and all these expert systems, which were very popular in the 1990s. This was about this theory. And then a significant achievement in this period was this IBM designed this deep blue computer that could really, that beat the world's chess champion, Kasparov, okay? And that was 40 years after the prediction, okay? So this is not something that you discover today and impact is later. However, this expert system approach did not work because there's no way you can really get all the knowledge and code it to a expert system. There's no end to it. Okay, so now we are in the third boom. Now in the third boom also, when I asked you this question, are we there yet? We are still in this what you call narrow AI. Narrow AI is about, there are artificial intelligence systems that can do particular things to solve a particular problem. But it doesn't mimic the human's intelligence. Going to the general level or even the superhuman level has not happened, and we don't even know whether it will happen. Yeah, so most of the AI applications that we use today are very basic, right? You search with Google, you talk to your Siri and ask for instructions, or you go to Google Maps and say, give me directions. There are robots used very sparsely, and health recommender systems. If you go and order something, you get sent so many advertisements. This is AI in action, but it's very, very fundamental. That's not what real intelligence is about. Okay, so at this point, let me try to give you an introduction to what AI is, because I know that this is a diverse audience and you don't know what AI is, and AI is a very broad area. So I'll give a 4-slide tutorial of what AI is, okay? So if you talk about AI, we can start with data science, because data science is something that we all have been using, and using that from maybe grade 5, you all learn data science. Basically, data science is taking data and do some analytics, medians, means, Fourier transforms, or whatever type of analytics to get some insights, okay? And with that insights, we can make decisions. So this is something that we have been doing for a long time. But what is AI? It is something that overlaps with data science. So the overlap of data science with AI is called machine learning. Okay, so machine is learning like a human. Now, how do machines learn? You have to take the data and extract some interesting features from the data, and you fit it into a model, which is called learning. And this model can make predictions. So this is the core of AI, right? Machine learning, which can make predictions. And from those predictions, you can make some insights, and that can lead to actions. So that's the traditional machine learning. And so more recently, we talk about deep learning. I know most of you have heard the word deep learning. What deep learning is, nothing magical. It made this learning process easy. Rather than having to extract features and do things, you can just give data, images, music, text, or anything, and do predictions. And I'll talk to you why deep learning became popular and how it was enabled. But then you can make decisions. So when you talk about artificial intelligence, it is this part of making decisions. But the core of artificial intelligence is this machine learning. So machine learning is nothing but predictions that can be done much better than just statistical analysis. And it can be done at large scale. Okay, so the current paradigm of AI is mimicking this machine learning as if it was the human doing this in their brain. So it's not the expert system approach. In the brain, what we do is we take input, and we have lots of neurons that takes these, processes them, and makes an output. So that is the process that happens in the brain. So the current AI tries to mimic this process. So when you talk about big data, that is your input. Okay. And computing power, that mimics that neuron action. So the current models, basically, the building block is a neuron, which fires based on some input. So that's the high-performance computing, and the output result is a prediction or machine learning. So this is a very simplified version of what a machine learning model is trying to mimic. Okay. And with this, we have, sorry, this may be very basic for you. There are different approaches to learning, right? So supervised learning. Supervised learning is a way that you give machine information and the machine learns a model. Now, in this particular task, you are interested in looking at images and separating cats and dogs. So what do? You take cats and use some dogs, and extract some features, and you tell the model that these are dogs, right? And then you give the features and they are cats, and it develops a model. So this learning process just learns through looking at lots of data, the differences between cats and dogs through its features. And next time when you give an input, it can say it is a dog. So this is a fundamental supervised learning approach. Then there's another learning approach called unsupervised learning. Now, the problem with supervised learning is that you need to have labels. When you are teaching the model, you have to say, this is a dog, this is a cat, but that's very difficult if you want to teach it a lot. In the unsupervised process, you don't do that. You take a lot of images and you take the features. And what the model does is it takes the features and it clusters them based on their similarity. And what it can do is to separate them based on these features. So it is for you to go and put labels later on. So this is like a clustering task. Okay, so this is another primary model of learning. And then the third type of learning is called reinforcement learning. Now, in reinforcement learning, you think of an intelligent agent, that is this agent. So agent is surrounded by some environment where you take actions. This is what robots do, right? And based on the action that the agent does, something changes in the environment. And based on this change, there is a reward that the agent gets. If it does a good thing, it gets a positive reward. If it does the wrong thing, it gets a negative reward. And that way, through many, many iterations, the agent learns to do the right thing. So this is the principle behind reinforcement learning. Okay, so this is just AI machine learning 101. And if you look at what we are doing today, it's the same thing, but doing it bigger and better, because we have more data, we have more power, so you can make the models larger. Okay, so this is not really any mathematical magic. Now, as you see, more recently, again, AI started this big wave, right? That wave started with this introduction of what we call deep learning. And these are the three people who are responsible for different types of learning, deep learning models. And they got the Turing Award in 2018. Turing Award is like the Nobel Prize in computing, right? They awarded this for their contributions in deep learning. So what deep learning enabled people to do is to take different types of data and not bother about extracting features. You could just dump the image or the text into this model, and the model is so big that it could learn things that you don't even believe that it would learn. But the building block is the same. A neuron that makes a decision, but there are lots of them, billions, trillions of them, right? That is the key to deep learning. And that is what generated this new wave of AI. But to remind you, this would have never been possible if there was no data, because the core is data. So if you talk about that algorithms, yes, it is the case, but the enablers were big data. Big data is data you and I generate, which has a lot of volume, high velocity, and high variety. So these models are capable of dealing with this big data. And then the computing power. Okay, so just because of there is data, you can't do much if there is no computing power. So high performance computing, and that enable deep learning, which means you could have these models that have 60, 70 layers, many parameters. So if you look at these little circles, you see each one is reflecting a neuron. Neuron is just making one decision, a binary decision, yes or a no. But lots of them in different stages mimics what the brain does. Learning little things, putting more context, and making a big decision. So this is the theory behind this. And you make predictions and you can take automated actions, right? So basically, all this hype about AI is about prediction, advanced prediction. Accuracy is that, can it do better than a human? Yes, or maybe not sometimes. But what is useful is it can deal with large data sets, which a human cannot do, right? If there are millions of images, a doctor who is looking for a cancer can't look at million images and learn. But because this is a machine, it can do it in large scale. And the second one is the scale. It can do lots of it. So even if the prediction is not accurate, as what a human would do, the scale and the complexity it can deal with it makes it useful. So the human expert who is making the decision will have a very narrow list of options to choose from. Okay, so that's why in a sense, you don't have to be scared about AI, because at this moment, it hasn't surpassed anything what a human can do. But what it can do is scale and accuracy. Okay, so now big data. Big data is growing, right? Why? Because you and I generate a lot of data. So this is the growth of big data. And sources of big data, if you look at it, there's sensor data, there's healthcare, you wear devices, you run with smartphones, you use WhatsApp, Twitter, Facebook, all that is data. Traffic, you use the phone to find navigation. Then there's financial data, entertainment. There's no scarcity of data. People are generating lots of data every day. So from that point of view, this will only grow. And then I talked about high performance computing. Now, we talk about Moore law, right? Moore law in hardware, Moore law in computing. Now we have a Moore law in these AI models. So as these models get better and better, the number of parameters are increasing. Can you see billions and trillions? Those parameters are those nodes that you see. So the more parameters you have, you need more power, more data to make the model better. So what has made this better is just the scale and the power. Okay, and this is growing. So I know whoever is worried about sustainability knows that this is not good for the environment, but it is happening. How do we control? Because these data centers that process these chat GPTs are taking lots of power just to keep the systems cool. So it's not an environmentally healthy thing. So I'll quickly go through some of the recent breakthroughs in AI, just to give you an idea of where we are at. So if you look at health, health is an area where AI has helped a lot. So there are these different types of disease detection technologies that AI has enabled, predicting diseases, predicting heart disease by looking at images of eyes. So lots of data, and you process, you find cases where you can predict that this person is going to get a heart attack by looking at the retinal image of the eye. Now, how did this come? It is just from learning. They take a lot of images, classify people who get a heart disease and not get a heart disease. And if a model can say there is some possibility, it's a good thing. Then drug discovery is another area where AI has made breakthroughs. And then obviously in this prosthetics and lots of type of medical applications. If you are a biomedical engineer, you will know there's lots of AI applications. And then in economy, manufacturing, there's a lot of AI that's being used for optimizing production processes. And this is a new concept called digital twins. Have you heard of digital twins? Basically, it's a digital replica of a cyber physical system. So by keeping a digital replica, which is up to date and has all the information of the physical system, you can do things like predictive maintenance and other things without having to deal with the physical system. So if you're a mechanical engineer, civil engineer, this digital twins is something that's becoming very, very popular. Then quality control is another area where you have lots of data and you can manage it, and automation. Okay, next one is transportation. Now, transportation has many applications of digital twins. Self-driving cars, they are becoming a reality. Traffic flow optimization, intelligent traffic lights, automatic license plate. So there are many, many applications. Again, as you see, this is all enabled by data, because if you get lots of information about cars or images, you can make it to those decisions. So now this particular picture is from 2 months ago. I visited Tokyo University in Japan, and I visited their intelligent transportation lab. And this is an autonomous bus. I sat on that seat. So this is a view of that. So the bus drives on the real road, changes lanes, looks at everything just without, yes, there was a driver sitting there. Otherwise, I wouldn't have gone in that, but the driver was not driving. This was all. Can you click on this to see whether you can play the right side? There's a movie. So this is me again when I was going in the bus. See, can you see the bus is making that right turn, detecting all the vehicles? So what it has is they have LiDAR to understand what is happening around. But more than that, the bus communicates with the traffic light. So it knows exactly when the traffic light is changing. So there's a lot of redundancy. I know it's a bit scary, but there's a lot of redundancy built into this. This project was led by that professor who is in Tokyo University, who has been doing intelligence transport since 1950. And this bus is now commercialized, but he has a lot of patents on that. It was impressive. So the last one, generative AI. Okay, so generative AI uses machine learning models to create original contents, such as images, music, or text. Now, this is the one that has caused a lot of anxiety this year, ChatGPT, right? In fact, this message was generated by ChatGPT. I went and asked ChatGPT, what is generative AI? Then this is what it gave you. So this says it's developing original content. But what it is doing is basically predicting. It's the same concept. But it has seen all the data on the web. Looking at that, it's predicting something interesting. Yes, there is a bit of training that has gone around it to make it give more intelligent answers, but it's the same technology at scale. So why this is causing problems is it looks like it's original content, but it's not quite original. It learned from you and me who put data on the web, and it is causing a lot of ethical considerations. So there are many, many tools which is causing headaches for us as academics, because we can't write questions that easily in the exams anymore, because students will go and find the answer there. But basically, Google's BART is a question answering system. ChatGPT-4, OpenAI, DALL-E is an image generation and code generation. You have all these, and this is not going to stop. I know we can try to get regulations, but it's not going to work. Okay, so with that background of AI, I thought in the next few slides, I'll talk about what I work on with my team in data analytics, machine learning, and big data. There are two main application domains I work on: traffic and transportation, and information warfare. So as I was telling Professor Lucas, just sitting here at Morotour for my final year project, we worked on designing an intelligent traffic light system, and Professor Lucas was our helper to help test our system. So it didn't stop. I'm still working on traffic, Professor Lucas. When we started, it was a long time ago. So this information warfare, what is information warfare? A threat to governments now is war from information. What does that mean? People talk things about on the internet, which is misinformation. So democracies are threatened by misinformation. So what my research, I'll talk about it. How do you detect this? So these are the two areas, but my focus when you talk about big data and real-time data. So when you say real-time, we want applications where we have to make decisions looking at data streams as they come. So they have a new set of challenges because big data stored in a system processing is easy. But if you have data coming real time, now you have a different type of model that you have to build, which is even more challenging to build because the decision making has to be done very fast. Okay, so traffic optimization. So we are talking about a connected transport ecosystem. So there are intelligent cars, there are autonomous cars, but more importantly, cars that are connected. Now, when you say connected, there are different ways you can connect. If I'm carrying a mobile phone in the car and somebody else is carrying a mobile phone and you're asking for traffic directions from a traffic authority like Google even, you are basically connected because Google knows about both of you. And also there could be a car that has a device that the traffic light system detects. So there's this connectivity, which gives you a lot of potential. I'm not so interested in making the system autonomous, but through this connectedness, I think we can improve safety because drivers make crazy decisions, right? And if you have connectedness and there's intelligence, you could do things to give warnings, or if there are ways you can get control over things before a driver runs a red light. That is the type of thing we are interested in. So this is the area. So one of our research contributions here is a large-scale simulation platform called SMARTS. So SMARTS can simulate traffic faster than real time at a level of car, and it can interact with real maps. So we take OpenStreetMaps, we put the traffic profiles, and you can see how traffic moves and make decisions. So there are a lot of use cases looking at how connectivity could help reduce safety, improve safety in the system through using these type of simulations. And the second research I'm showing you today is contributions from one of my recent PhD students, a Sri Lankan student. So he looked at 4 different problems, right? One is autonomous intersection management. If you have a 4-way junction, how would you try to not operate it without traffic lights? Now, this is an old problem. People have looked at it as civil engineers long time. But what is different in our approach is we are trying to do a data-driven approach, reinforcement learning, looking at how drivers make decisions using this data. Can you design an algorithm so that you don't have conflicts in the intersection? Okay. Dynamic lane configuration. What is this? You know that on Gaul Road, right? In the morning, you'll have 3 roads going this way, 1 road going the other way, and then you turn it. Can you do that automatically? Because if the cars are connected and autonomous, you can do it dynamically, you can do it faster. You don't have to have that person coming and moving the cones. So these are the algorithms. And dynamic traffic optimization, this is like a bit of a theoretical work, but can you come up with algorithms that will look at the dynamic aspects of roads, vehicles, and all that, and automatically come up with a combinatorial optimization solution to a traffic problems using machine learning? Now, the advantage of using machine learning as opposed to linear programming and other techniques that you would know is the speed at which it can do it. It can do it in real time. And finally, safety management. Okay, again, algorithms to manage safety while keeping the flow good. So these are some publications from this PhD. And the second aspect, as I said, so there's lots of other topics on research on traffic. You can go and look at publications, but the second aspect is this information warfare. So if you look at Twitter and all these other social media platforms, that has become a very fertile ground for misinformation propagation, right? If you look at the American elections, you know that it was all messed up by different types of actors trying to mess with it. And it happens in every election now in the Western countries, right wing, left wing, trying to do this. So this is the dark side of AI, right? It can do good things, but people use it for bad things. So the particular challenge I'm looking at is how do you detect misinformation on social media in real time? And this is one of the articles that got published in the Australian earlier this year on my work. And the system we have developed is called RAPID. Again, it's a big data processing system, real-time analytics platform for interactive data mining. What it can do is it will get social media data streams, real-time online 24/7. It will get these streams, and this particular system processes these using machine learning algorithms, and it is able to show you interesting things or anomalous things. Who are the bad people? What kind of communities they are building? What type of activities are going on? So this is research funded by the Australian Defence. So it's a little bit sensitive. We don't get into details, but we do provide things. So in terms of research contributions, this is again one of my PhD students' work, cross-domain misinformation detection. So when you try to detect misinformation in social media, one of the challenges is that there are different domains. Models are not very good at identifying, going across domains. So this work was looking at how they do it cross-domain. I'll go through this quickly, the different contributions, okay? So I'm still working on this area, but there's a little bit of challenge with the Twitter data being shut down. There's a little bit of challenging in getting access to interesting data, but there's a lot of work going on that. So that's a very brief overview of the work we have done. Now I get to the last part of my talk, which is the title, Harnessing the Power of Big Data for Economies, right? Because we are trying to do innovation. How do we do innovation with big data? Now, with all this hype of big data, I know that companies are trying to use big data. So this is a PricewaterhouseCoopers business survey report, which shows how companies have adapted AI. So they have classified some companies as leaders in AI and some as others. But this shows you the percentage use of AI. Some 36% say they are fully enabled. Somebody says limited. 14% says proof of concepts, but not quite testing. So, okay, so there's adaptation, but not a lot. And what do they use it for? Again, this is a survey result by PricewaterhouseCoopers. They said they use it for increasing productivity through automation. They said the top 5: improve decision-making, improve customer experience, innovate our products and services, and improve employee experience and skills. Okay, so that's the adaptation. But for businesses, the main thing is return on investment, right? For a business to run, you need to get money. But what it shows is, although companies are investing on AI, the returns are not good. So they are questioning, why is it the case? Now, we don't know the case, but I believe this, I listened to this by a economics professor in Toronto University. So what the way he says is, we are in the between times. We have found this technology, which is very powerful, but we really don't know how to use it properly, okay? And the analogy he says is going back to our industrial revolution. If you look at The patent for the light bulb is from 1880. And Tesla's patent for electric motor is 1887. However, the effective automation of the factory did not happen till 1920 or 1930. So there was a 40-year period before it was put into use. The reason, which is argued in this paper, is that when steam power was replaced by electric power, the people who tried to automate the factory did not really go back and look at what is the best way to use it. They replaced the steam motor with the electric power. But until 1990, when the factories look at the flow of the workflow and say, this is how you better use electricity. Until then, we did not get the full power of electricity. So maybe with the AI, we are in that stage. We have found this technology, we are doing little incremental things, but maybe we need to think through how to use it for the betterment of people, not for the deterioration people. So this may be one problem. And also the last thing is AI has a lot of challenges, right? I talked about the good side, ethical considerations, right? To some extent, we will take models from big data. It's other people's data. It's other people's IP, people's creativity. Are we stealing that? Are we acknowledging that? Are we paying that? Or are big companies just making money from people's innovations? Lack of trust and explainability. This is a big issue. As I showed you, that AI model is a bit of a black box. You put something in, put a lot of nodes, and something comes out. It's not like a mathematical formula, right? You can't explain why you made that decision. So would people trust it for things that really matter to you? It's a mindset change. Privacy and security. Okay, without knowing, we go and do Google searches. We give all our data to those companies. Now, when we're setting exam papers, just to check whether the student is cheating, we go and put our question on ChatGPT to say what answer it gets. ChatGPT gets our question, right? They get better. So they're stealing our IP again. So whichever we try to do, we are the victims. The companies are the winners, right? So we have to be mindful of all that bias. Now, this is something people argue because AI goes based on data. If the data has bias, the model will be biased. Now, I say if the data is biased, that means the people were biased to begin with. So AI is learning our bad habits, but maybe that is not the way to go. But the biggest challenge is bad guys, right? People do cyber attacks with AI. People do stealing with AI. People spread misinformation. So responsible use of AI is very important. So I was listening to this professor talking about this cybersecurity professor. He said, as AI researchers, we'll have to sit and think about it, right? The way he put it is, he said, we have reached this Oppenheimer moment of AI where the person who created the atomic bomb did not realize what bad things it could do. Will AI be a technology that will be used that way, and would we all regret? So I think policy regulation will be necessary. It's a powerful technology, but to use it, you have to be educating our young generation on the responsible use of AI, ethical use of AI, and making them aware of the possible consequences. So where are we going from here? Going to Industry 5.0. I think it's very important to have the human in the loop. AI can be a helper, but AI shouldn't be the decision maker, right? Because I think humans, when they make decisions, they have a lot of experience and ethics, and things are built into humans. I don't think we will ever get ethics built into these AI models. So we have to be mindful of that. And sustainability is something we have to think through carefully, because you can process data centers consume lots of power, which is not good for the environment. So in conclusion, deep learning has enabled a new generation of AI which has done wonders, which has done beyond what the designers thought. So especially these models like ChatGPT, they were testing it for a while. We had the research access before that also, but they were generating results that OpenAI couldn't even believe. And only thing they were doing was making the model bigger and bigger. And the bigger the model got, it learned better. Okay, it has great potential, but proper use, responsible use is important. I believe human in the loop is the most important aspect, where human user will use AI as a way to get help rather than let AI lead you. Okay, so as I finish my talk, I remind everybody with great power comes responsibility. It's you and I who will be educating students about the responsible use of AI. And this is my research team. I would like to acknowledge everybody's contribution there. And thank you for listening, and happy to take questions. Okay.
At Harvard and Harvard and Stanford maybe have, but the other universities. So basically, as a researcher and working in the high performance computing, how do you comment on that?
Okay, so the question is around, at the moment, whoever is developing these models, they are doing it because they have the power, they have the money, they have the computing power. So how would the average user use AI? Now, this is where the battle is. You know, the Elon Musk and all these people, OpenAI directors, they put the models and say, now we need to regulate AI. It's AI has gone too far. They want control, right? And I think just like we did cloud computing at the edge, we need to get to models where we'll have AI at the edge. So the models, if you can develop more distributed models that can run on the cloud, I think it will be a good way to go, because you're not putting data in one. Have you heard of the word federated learning? The federated learning approach is like that. You learn from your data. You don't share the data. You share the model, and the models. I think that is the way to go. But the problem is these big companies who got their edge or their business case because of that. And so this is where the last I said, we have to think of new ways of using this technology. Maybe it's not as good as ChatGPT model, but we should start building. And also, if you look at some of these large language models, which are open source, they're not as good as ChatGPT 3, but you can run it on average size machines, not at that scale. Yeah, it's a good question, right? It's at a stage where the powerful people have got the technology, and they're trying to see how they can control the world, because they have the data, they have the technology. We have to think differently.
So my another question is that, so basically if we consider the information and Twitter and all other things, so I have seen that some people have used the deep geometric learning and the graph, they model them as a graph and work on. So I think now the one developed that model is one of the chief scientists at Twitter at the Imperial College London. So how did you model this in this? Is it a graph based or deep geometric model or another model?
So we used a multiple approach. So ours is about multimodal learning. We're learning from different modes, not just text, but something which was very important for us is how messages propagate. That gives a lot of information. The misinformation propagates. When I say propagate, how people share, they're different. So that was really modeled as a graph.
Okay.
Yeah, so you use a graph neural network, model that, and also that it's a space-time graph. So how it propagates over time. So in that model, you take that, text, and even images. So it's a multimodal representation learning is what we're looking at.
Yeah, great. Yeah. So another question I have is basically, since you are a good educator as well with the ChatGPT and STEM, all of these things. So basically, it's a challenge one way, but what I feel is that I did one research with one of colleague at the University of Queensland. What we found is that it would be a good way to basically personalize learning. So what's your view on the ChatGPT and generative AI, the good aspects?
This is, as the deputy dean academic, this is my biggest headache at the moment. So here is University of Melbourne's position. Now, there are many faculties in the university, right? Arts faculty wants one thing because they are worried about their creativity. The music, fine arts requires another thing. And then there's the math faculty has a different requirement. So the university put a policy saying that no AI used in any type of education. This is what the university put as policy. So I'm in the faculty of engineering. That's where the computer science are. Now they're in a war with me saying, can you please go and challenge this, because this is our research. We know what to do. So as you are speaking, I'm writing this paper to say, relax this for people who know. I believe, like you, it's a good way to educate, personalize. But again, there are a lot of considerations, right? So even to personalize, the student is putting their data, giving it to OpenAI. Yes, it's the student's IP. In a model, I think it's not that possible to copy it, but we as educators have a responsibility to look at the legal implications of it. Maybe here it may be not that important, but the reason why university put this thing is because students own their IP. So if we as educators use it for even giving feedback or marking, we have violated the law. And a student, if they do the same thing, or there are a lot of things you can do, but again, that aspect of, is this right or no, right? Can we use students' IP to generate models even to improve their learning is not known, right? So there will be some regulations that will be required, but I think this is what keeps me awake at night, because this is trying to fight that war of university trying to take a very safe approach so that they don't want to hit the newspaper saying University of Melbourne uses ChatGPT to mark student assignments versus all these academics wanting to do interesting things.
Bit of a philosophical question, but very happy to see your applications. For example, the diabetic retinopathy, University of Moretu has a spin-off effective solution.
So this one, that one was not really my research, but
No,
it's
no, no,
whatever
but
research.
one of our own graduates have done a similar thing, and today has a company which provides a solution. So
yeah,
encouraging to see most of these ideas are being actually done here as well. My question is, now if you take Moratua, for example, there are multiple research groups working on various building blocks that are needed. For if you take Sinhala or Tamil languages, the translate all those. And Sri Lanka right now has a tremendous emphasis on AI research. I mean, President has promised 1 billion or 100 billion rupees in the next, like that. But how do we leverage, how do we combine all these? Well, I mean, this is more for my young academics to think about, because there are a lot of building blocks being built. The Sulochana's IntelliSystems Lab, Professor Dias's NLP Lab, all data search. How would you see us as a university or as academic community working together to bring these building blocks in a much more broader platform?
Yeah, so it's not just a problem for you. We are struggling with the same thing at Melbourne because everybody is doing their beta of AI. So we created this institute very loosely called AI at Melbourne. Now, it's not anything that has any physical presence, but just to bring the community together and give talks on what they're doing as a way of connecting them, because there are a lot of things people are doing. They can benefit from each other. Again, we have not, and every university has this problem. I see University of New South Wales did the same thing, because normally there's no funding to bring things together, right? Everybody gets funding to do that. So either somebody has to invest time on getting these thing together with some administrative support to do the activities. But if you're thinking of building platforms or software, something you can't keep up with, right? It changes every day, it changes. So there's no solution, but you can only keep trying. Yeah, it is a question. So Melbourne, there are so many people and we don't even know who is doing what anymore. So we created this big thing called AI at Melbourne, which is nothing but a name which puts everything in together in one page where somebody can go and find out who is doing what so that they can talk to each other. And in research communities, everybody is doing their own thing. They don't have the time to go and even talk to the other person to find out what they're doing. Any more questions, students? Do you have any questions? Yeah, okay. Yeah, out of time? Okay, okay.
So do you consider generative AI to be the next thing? Because now generative AI can generate code even. So like Code Llama, and we can use GPT, GPT-3, GPT-4 for text-based and even image-based generation. So would you think that link between human and machine can be done through this generative AI?
I think it is the direction that is going, and there will be a lot of things. I don't know whether it will mimic the human, but it's getting very close to it, right? So if you go back to my first question, can you differentiate some of the things that AI generated? You can't really differentiate. You can't say that AI generated it. Now, high-level thinking, maybe not, but I can see that companies will eventually use these ChatGPT type interfaces to improve their workflows, even to write letters, right? It's much easier to get a draft written by ChatGPT. So it will get into the workflow, but you have to be very careful knowing where to draw the line. Okay, so I've been reminded that I'm out of time. Thank you, everybody, for listening. Thank you again for having me here. And I enjoyed being here. Thank you.
Ladies and gentlemen, I extend my deepest gratitude to Professor Shanika Karunasekara for gracing us with her presence and delivering a truly enlightening keynote speech. Your insights into the world of artificial intelligence has truly left us in awe. Professor Shanika, in appreciation of your presence and profound insights you shared, we have prepared a small token of appreciation. To present this token, I'm honored to invite the Program Chair of MERCon 2023, Dr. Sulochana Suryarachi, who is also the Director of the Engineering Research Unit and a Senior Lecturer at the Computer Science and Engineering Department of the University of Moratuwa, to join us here. Professor Shanika. Okay.
Once again, thank you, Professor Shanika Karunasekara, for gracing us with your presence and sharing valuable lessons on artificial intelligence. To all the attendees, thank you for your enthusiastic participation. Your enthusiasm and engagement make MERCon 2023 a resounding success.
As we delve into the discussions and discoveries of this session, I encourage you to embrace the opportunity to learn, share, and collaborate. Let us continue this journey of exploration and innovation together. Once again, thank you for being here, and I wish you all a fruitful and inspiring session ahead. Thank you.